Nancy.
Great, so I think we're just about ready to get started. So hello everyone and welcome to NYC Builds Bio's webinar entitled Expanding New York City's Life Science Footprint, a case study on Georgetown and Icahn School of Medicine at Mount Sinai. Thanks so much for joining us this afternoon. My name is Nancy Kelly and I serve on the steering committee and as a founding member of NYC Builds Bio. First, I want to acknowledge and thank Vanderweil, who is the sponsor of this event. Vanderweil is a full-service engineering firm specializing in MEP and technology services for a wide variety of buildings, sustainable design, commissioning services, as well as central heating and chiller plants, power generation, and electrical transmission and distribution lines. With a staff of 450 located across 9 offices, Vanderweil is one of the largest independently owned engineering firms in the country. And of course, the founding and corporate members of NYC Builds Bio make all of our programming possible. I'd also like to welcome my fellow co-founder, Mitch Simpler, who just said hello to everyone. Hi, Mitch, thanks for joining us.
My pleasure. Welcome, everybody.
So the Icahn School of Medicine at Mount Sinai, a leading research institution affiliated with Mount Sinai Health System, has signed a long-term lease for 165,000 square feet at 787 11th Avenue in a mixed-use conversion development by the Georgetown Company. Now the anchor tenant, Mount Sinai, leased more space than the total life sciences footprint leased across New York City in 2020. This transaction is pioneering for life sciences in New York City in many ways. Georgetown converted an existing commercial building for life sciences use in a developing life sciences subcluster years before leasing the building to Mount Sinai. Mount Sinai leased 165,000 square feet in one of the largest transactions between an academic medical center and a private building owner in New York City. This happens routinely in clusters like Boston and Cambridge, but is relatively new to our city. The combined clinical and research use plan for the facility illustrates an important trend in life sciences. And biodesigner Neri Oxman, who also leased space in the building, represents another important academic tenant in a groundbreaking field of life sciences, biomedical engineering. And finally, the banking and service providers demonstrate the breadth of value a life science transaction such as this can mean for many industries in the city as we emerge from the pandemic. Our speakers include Jonathan Schmerin, Managing Principal, the Georgetown Company, Representative Raphael Vignoli, Architects, Jim here, Jim Path, Senior Managing Director, Guggenheim Partners, Thomas Ahn, Vice President, Real Estate, Icahn School of Medicine, Mount Sinai Health System, Stephen Dietz, Partner, Mitchell Gargiola Architects, Paul Drago, Managing Principal, NK Architects, Brian Aroni, Senior Vice President and Project Executive, Hunter Roberts Construction Group, and Joan Raso, Engineering Principal, Vanderweil Engineers. Welcome everyone, and thank you for joining us today. This webinar is part of an ongoing series of online events hosted by NYC Builds Bio. You can view the series on the events page of the NYC Builds Bio website. And please register for our future monthly webinars in May and June. On May 25th, we will feature the Cove JC, a global hub for life science, technology, and lifestyle, which will be transformational project for the greater New York metropolitan area. On June 8th, BAM Creative, Millrose Consultants, Skanska, WSP, Safety Partners, and other professionals, including Deerfield Management and the New York City Economic Development Corporation, will share the basic understandings necessary to develop a successful laboratory facility and the unique cost drivers behind delivering value and quality. On June 17th, Taconic Investment Partners will offer virtual tours of the Hudson Research Center and the West End campus, a 3.4-acre assemblage on Manhattan's Upper West Side, meant for state-of-the-art, purpose-built research and laboratory space. We also hope to announce in-person, celebrate, virtual tours of new developments or in-person tours of new developments commencing in September with Deerfield Management's 345 Park Avenue South, called The Cure. A date will be announced for that event shortly, and we hope you will all join us in this rich programming. Before I begin, just a few administrative details. There's a program and PowerPoint highlighting the hosts and speakers for the meeting. These will be posted on the NYC Builds Bio website after the meeting. The program is being recorded and will be distributed to all registrants after the meeting. If anyone's having technical difficulties accessing the Zoom room or other issues, please email info@nycbuildsbio.org or send a notice through the chat button at the bottom of your screen. Since most of you are participating in listen-only mode, please feel free to submit your questions via the Q&A button at the bottom of your screen. We will open up for discussion and Q&A at the end of the program, and will address as many audience questions as possible. At the end of the meeting, we will also have a chance for smaller randomized groups to meet in separate rooms where you can open your videos and microphones to talk to each other. You can stay as long as you would like to get to know each other or share stories. Now I'll open it up to Jonathan Schmerin, Managing Principal of the Georgetown Company, who will tell us a little about the decision-making process Georgetown went through in deciding to prepare 787 11th Avenue for life science conversion.
Thanks, Nancy. Really appreciate you inviting us, and it's an exciting topic. And thanks to all the folks on the panel as well, many of whom we had a long fought battle to get to the finish line here. So thank you to all of you. So Georgetown, a New York-based owner-developer, acquired the building in 2015. It was previously owned by Ford Motor Company. The entire building was a automotive sales and service facility. As we looked at a possible acquisition, we were cognizant that it was one of the few locations in Manhattan that had the necessary zoning, along with the floor plate size and sort of some of the base building bones that could ultimately accommodate life science. And so as we went about our redevelopment plan, we were mindful to provide for both space in the basement for mechanical space. We were mindful to keep the existing floor loading to allow for heavy density use. We inserted a bunch of shaft space to allow for pathways up to the roof, and then kept a portion of the roof unutilized for ultimate additional mechanical equipment that we thought a life science user would need. And so I think we recognize the importance of life science to Manhattan and the proximity to Mount Sinai's West Side Hospital. And we're optimistic at the time that we would ultimately land a life science user. We're thrilled that Tom and his colleagues have decided to join us for a long time at our building.
Great. Well, that was prescient, right? Somewhat just kind of gauging where the market was and where it needs to go. And, you know, the analysis you did and the questions you asked are on the mind of a lot of building owners these days in New York City. So that's one of the reasons that I think this case study is so important for us this morning. Jim Yer, Raphael Vignoli did some of the upgrades necessary, the initial upgrades necessary to bring this building into shape to be able to accommodate life science use. Can you describe the process you went through with the building owner and talk a little bit about the challenges you faced in installing those mechanical systems and other improvements?
Sure, thanks for having us. Is the PowerPoint on?
Yes.
Okay, let me just, there we go. Okay, great. So I'll take you through, we just tried to pull out some slides from the past, I guess it's almost been 6 years now. So to kind of tell you a little bit of the story of some of the obstacles that we all went through, the team. And I'd like you just to walk through it. So next. So as you're all aware, the building was originally the Packard Motor Building. It stretched from 44th to 45th Street, an entire block, and then half a block from the avenue over to the West Side Highway. And what was interesting about this, the reason why I'm showing this slide is it kind of is the impetus of how Georgetown decided how to move some of the floor area of the building around. There was a rooftop automobile storage facility, which was part of the original design, and it had the helix ramps that came up to the roof. Here you can actually see the some of the Land Rover ramps and whatnot. Next. And the building was originally designed, believe it or not, was by Albert Kahn, the preeminent architect of the in Detroit of most of the major automobile fabrication facilities that as architects we all admire and pretty amazing. We actually didn't even know he did a building in New York City until even after we went to see the site with Adam and Nana the first time. And it was like, wow, so this is really an Albert Kahn. And of course, a lot of it had been, you know, adjusted over the years, but the basic bones and the structure in this automobile ramp was intact, which is pretty amazing. So we were just thrilled to be able to be, to try to extract some of the history, which I'll show you a little bit later on. Next. Another image from the 20s. Of the building, and you can see some of the ornamentation of the fluting of the columns. There's rosettes at the top of the building, and then all the windows had these horizontal spandrels, which kept the automobiles from crashing through the facade. Next. Now, here's a fantastic picture that we use a lot of in our meetings every week, but this shows the helix, the double helix of how access was actually made on each floor by the automobiles. Next. And then before Georgetown took over the building, this was the state of the building. Right before that, there was a granite, pink granite facade that was added at one point, but essentially most of the windows in the building was there. And so this is a picture on 11th Avenue looking south. Next. So this is the first time we actually went up there. And you can see the terrain track by the Land Rover, but it has this 8-foot high parapet wall, which is essentially like a room at the roof, which contained all the automobiles. And next. And what's you can see this is how the helix ramp came up to the roof, and then there was water tanks and all sorts of things, and a big boiler flew. Next. But what was really neat was these amazing views looking southwest, north. Next. Which really gave value to even the new floors of the building. Next. On the right, you can see just a picture of one of the internal helix ramps. And on the left, you can see the windows and the spandrels. And I'll talk a little bit more about that in a few minutes, but we had to modify some of those things. Next. So this is a little small, but this shows you the stacking of the building as it originally was, and then how the building was going to be maneuvered. So the ground floor plane has a blue slab, and that was where the first floor is divided by. That's where all the automobile showrooms and access for the vehicles would come in and come out for service. And then below that in yellow is the cellar where we put in the mechanicals and The reason why the cellar is only halfway of the site is that the rest of the site going towards 11th Avenue is basically bedrock. And so that was an important decision where we decided to place the core because obviously we couldn't dig out all that rock under an occupied automobile showroom. So, and then as you go through the floors, the blues were the automobile floors. And then as you get to level 6, we were going to make that a double high space. So the impetus of the whole, regardless of design, of how to make this thing happen was that we were going to take the level 7, open it up and make the 6th floor double high space, and take some of that floor area from level 7 and put it on the 2 levels on level 9 and level 10, which are the new floors. We're reallocating the floor area. And level 8 was essentially where the existing roof was, but we had to remove that roof and build a new floor so it had the proper floor-to-floor height up at that level. Next. So in section, you can see the stacking of the programs. Again, the blue is the car floors, and you can see this is where we cut on the right the helix. So we had to remove that helix from the 6th floor upwards, which was a major structural thing. The thing was really built, it was all beams basically, right? So, and then on the 7th floor, you can see that we would open up those double high spaces on the left area. And then on the 8th floor was essentially the roof, but we actually removed the roof where the parapet was, added the floor, and then built the 2 new footprints on the top of the penthouse with the zoning setbacks from the streets above it. That's floors 9 and 10. And then there was the tennis court. One time there was a pool which was removed, and then the mechanical penthouse on the right facing west. Next. A little bit more detail of how we took the existing high parapet, lowered the floor, and that gave the 8th floor to have a significant floor height to it. And then we added the 2 floors on the 9th floor with the setbacks on the streets. Next. So constructability terms, on the left is the existing building, how it was stacked. There's the rooftop and the access to the bulkheads. There was no core actually in the building. As you would consider a passenger car, because there was not really that many occupants. It was all automobile. So there was a tiny little elevator that serviced the mechanic floors and fire stairs, and then an automobile elevator on the north. But essentially, everything was used by the helix ramp. So the first thing we had to decide was to put in the middle diagram is where do you put the core? And then we had to remove in red the entire roof deck to build the new floors, because also it needed to support the new floors. And then on the floor below in red is where we had to manipulate the 7th floor to take that area and put it on the top. And then on the right shows the configuration of the proposed design with the rooftop and new mechanicals and the new elevator bulkhead. Next. So quickly running through the stacking on the upper plan is just the parking level where we had to add new mechanical levels, a new retention tank. This was actually the original loading dock, and obviously we couldn't have a loading dock down the ramp. And so we built the new core into as much into the rock as we could beyond the foundation wall. And then on the plan below is the new loading dock that we put on 54th Street. Next, I'll just walk up the building. So the new lobby for the building was in the centered on 11th Avenue with basically the car showroom to the left and another car showroom to the right. And where the lobby ends was basically the cross circulation of all the cars. So the automobiles would come in to the left, they go up the ramp and they come back down, and then they exit to the right after they were repaired and whatnot. And so that would determine really the placement of the core that you see in the middle of the plan. Next. Again, the automobile floors. Next. And then this is the sixth floor plan. So it's 60,000 square foot footprint, and this is a little bit earlier, but allocating all of the mechanical rooms and shafts and the other mechanical rooms in the back and the exit stairs were one of the early things to do. Next. So this is one of the configurations that we had. They ended up to be on the south side was the double height space. We actually spent a lot of time trying to figure out where the double height space would be. So this was the seventh floor. And I'll show you a little bit later in a minute or so about how this was actually built by the team. Next. And the new eighth floor, which was the roof of the existing building, basically was an open office with the 14-foot high heights. Next. The new setback on the penthouse. Next. The upper floor of that. Next. And the roof, which ended up to be a little bit different, but essentially core and support in the middle, some amenity space to the east, tennis court, and then all the double height, 2 floors of mechanical in this large bulkhead, which faces west. Next. So on the upper left is the roof slab removed to get to the 8th floor slab, which then would be rebuilt. You can see a portion of it, the ramp, helix ramp was removed. This is during demolition, and then the crane was brought in, set into that floor. The next slide. And we started to build the 2 new floors on top of that, and on the left is the elevator override and the mechanical rooms above the elevators. Next. The elevators were a significant feat because it was basically in portions of it was in rock, and it just was like was really the early decision. And so we made at least the excavation and the shoring and whatnot for that long before we were even thinking about design items. Next. And of course, evaluating egress, stair capacities, and things of that nature was another decision on the early core studies. Next. Okay, so I'm going to talk a little bit about the windows real quick, so you can understand why the windows were ended up to be the way they were. Next. This is the existing building. So the part of the strategy was to open up the 7th floor so that we could take that floor area and put it into the building and make the project viable. So how do we do that? Well, we had the structure was actually pretty amazing for that time. It wasn't cinder concrete. It was actually reinforced concrete with conical capitals and drop slabs to help the shear because the loading was so significant. Next. So we had to remove the slab, and then what do you do with this, right? This is not a good space. It's also not a good structure. So so we had to. Silman was the structural engineer, just amazing how they came up with the ways of how to solve that. And so the next picture, we had to remove that, reinforce the columns with these collars, straps that would tie the 2 floors together. Next. And then the same thing would happen at the windows, where which I'll tell you a little bit later. But there's a lot of problems with the windows and how to make them the way that they are, which I'll show you a slide in a second. Next. And then this is a rendering of how we envisioned the double high space after all the structural work was done. Next. So a little bit of the construction of that was, first thing we had to do was get to the meat of the columns and chop through. It was a horrible demolition work. Chop through the capitals to get to the internal columns, and then well, the picture on the right is actually more finished. You can go to the next slide. On the left and on the right, you can start seeing how the collars were getting ready to be installed. The floor's been removed. The internal other capitals were already removed, and then everything was getting ready to be reinforced. You can see on the right side, of course, everything had to be braced. It was quite a dangerous operation during that construction. Next. And further along. Next. So the windows. So I mean, it may seem like a not so important thing, but when you realize that the floor plates are 60,000 square feet, huge, and you look across and there's 14-foot ceilings, you're like, wow, why is it so dark? Well, the window sills were actually like 4.5 feet tall. I mean, they were super high. And that was basically to keep, they put a concrete spandrel across there to keep the vehicles from crashing through. And so that was an incredibly important decision. So I'm going to walk you through a little bit of that process of how it happened and things that we found as we went along. Next. So this is the existing exterior condition. There was fluted columns, these spandrels with pediments that were pretty interesting. Next. Take out the windows. Next. Take off the spandrels. Next. Remove those concrete spandrel beams that were there. Next. And start to fill in the windows. Next. So from the inside was important because you had this condition. Next. But you wanted that. Next. What does that have to do with the building? Well, so originally one of the ideas for the facade was kind of typical of 11th Avenue. You would take this old building that had all these different things, different programs, new additions, and you try to make a unified facade, which is a mesh screen. And then we said, well, that's no good. Next. And then we said, well, why don't we take a little bit more literal track? And that was to wherever you have a double high space, you would make double high windows. And then we couldn't figure out exactly where to put that double high space in time. So we said, well, let's think of something else. Next. And what we found as we started to remove the scaffolding was that when Albert Kahn did the building, there was actually still some things there that were pretty interesting. This gargoyle and all the fluting details were pretty much intact, not all, everywhere, but enough where we could replicate it. So next. And so on this is more of a finished rendering of what we did. And you can see on the upper 3 floors of the building that the spandrels are actually much thinner, and that's to get the window height. And that's all that structural work that we had to do to make that happen. And the lower floors where the garages still are, the automobiles, we kept the spandrels intact. And we thought that was a completely fine resolution to all this process. Next. So I guess, I don't know, I can't remember Jonathan, but one day Joel came into a meeting, says, by the way, we've got to put a whole bunch of new shafts in the building. And we're like, really? Okay. And so we did this is just one little plan, but we did this overlay to find out where can we put in this extra area of shafts. And we immediately did a program where they kind of thread their way through the building without too much impact, and then made the new openings, put new steel, took the steel out, and adjusted pretty much right away. That was the thing with the team, is that they would just, as things were thrown at them, they would just attack it and make it happen. So that was really cool. That was really a lot of fun. Next. So the lobby. So what we had found was that we had all these different things. There was an automobile showroom room to the left, and another one to the right. And then there was the building, which had this, this linear horizontal demarcation across the second floor. And so why don't we make the lobby a void of that? So we've made this dark negative, dark meaning dark color, with a recess for the entrance because of the core so deep, to give a protection and an entranceway that was enough of an impact to show you where to go into the building. Next. So, so for the lobby design, we pushed the storefront and the revolving door enclosure back into the first column bay. And that was just to kind of reduce the length that you had to maneuver through the lobby to get to the core. And the core design was really mostly based on traffic. You would go, you'd go in on the right, you circle around the desk and enter, and then you would exit to the left, and hopefully it would direct people without clogging up the circulation of the lobby too much. Next. Right, there's a view from the recess into the lobby. Next. Yeah, and next. Next. Great, thank you very much. And thanks to Adam and Jonathan and Joel and everybody at Georgetown for the wonderful years that we had trying to figure this out, and the entire construction team that was who we got to know really, really well. We had a great experience. Thanks.
Wow, thank you, Jim. That's amazing. It's what's really so interesting to see that a building that housed, you know, the foremost industry in its time in the beginning is now being repurposed to house another industry of the 21st century, right? Life sciences. It's just amazing. But Jonathan, all of those improvements seem pretty daunting. There's a lot of stuff that happened there. I mean, was there any time when you basically said, wow, this is just too much, we need to go in a different direction?
No, we have a great partner who wanted to occupy a portion of the space, some of the office space, and we were working in advance of our acquisition on the automotive side, sort of as a precursor to last mile logistics. We sort of were comfortable with the notion of having automobile space in the building, again, because thought that having distribution, even though Amazon was not as prevalent as it is now 6 years ago, it was clearly a trend that was coming. And so keeping some quasi-industrial use of the base of the building made a lot of sense to us and worked harmoniously, especially with the way Jim and his team came up with that center core coming through the building. It allowed us to have ground floor uses a la Park Avenue, right? You have retail storefronts, there's a Ferrari store on Park Avenue, and yet you enter your office building in the middle and then go up. And so what happens on the lower floors was somewhat irrelevant, assuming we were able to control both noise, smell, vibration, which we've done. So it was certainly a lot of work. It took us probably about 2.5 years to execute, but we're thrilled with the outcome.
Terrific. So now I want to turn to Thomas Ahn, Vice President of Real Estate for Icahn School of Medicine. And Tom, can you take us through a little bit of your decision-making process? You know, must have begun actually internally with an evaluation of the uses that you needed, both clinically and from a research perspective. And then how do you translate that into finding a place like this?
Thank you, Nancy, and thank you, everyone. You know, this is a process that took a long time, actually. This should be really a case study. We started our actual search in 2018, pre-pandemic. So it you know, this sourced through a long period of time. I'm glad Jim went through his slides, because wet lab research facilities require very specific characteristics from an infrastructure standpoint and a physical standpoint. It commonly, you know, wet labs commonly like high ceilings, wide column widths, and large floor plates, which this building has. The column widths are about 30 foot on center. The ceiling heights, as you saw in some of these drawings, are around 15 feet high. And the footprint there is approximately 60,000 square feet. So it kind of ticked off all the right elements. I should also say that only certain parts of New York City have the proper zoning requirements for wet lab facilities. We were looking for a site that could house a vivarium, So that's a facility that has animals. So our vivarium contains mice, and that was an important piece. So a lot of buildings in New York City do not have the capability of housing that kind of facility or any interest in housing that kind of facility. So part of, and let me just give you a backdrop of most major academic medical centers in New York City. If you look at Mount Sinai, NYU, Cornell, Sloan Kettering, Columbia, all of the major science buildings that have been built in those centers have been on campus.
Mm-hmm.
You rarely see a lab building that is not within their main campus. And as Nancy, as you pointed out, this is the largest biotech lease that was signed in the city by a major medical center. Scientists like to be close to home, close to the mothership, where the dean is, where they're teaching, where their medical school is, and to be away from that main campus is unusual. We had a specific need where we were expanding our laboratory footprint. We didn't want to build a building for just 80,000 square feet, which our lab is in this building. Typically, lab buildings are in excess of 500,000 square feet, so we weren't prepared to build a building this small for this purpose. And if you look at historically at any major medical center in New York City, every 7 years there's a cycle of a new science building being built. NYU just completed their new science building. Columbia just completed a new science building on their campus. Memorial Sloan Kettering and New York Presby had done something on the east side. So there's a constant expansion of wet lab space in New York City, but mostly near their main campuses where their medical schools are. We had embarked on a search in 2018 simply because we had this small requirement, but it was key for us to grow some of our programs on our main campus. We not only looked, and I'm going to tell you some of the buildings that we did look at. We did look at the one that you mentioned, Nancy, the Deerfield property. We looked at the Tasty Cake Factory, which is in Upper West Harlem. We looked at the Alexandria near NYU and also in Long Island City. They just have a new development going on there. We looked at the Hudson Research Center, which is owned by Taconic. All buildings that have those kinds of elements, physical elements that wet labs need in order to operate. So it was a long search, and then we were very close to completing a transaction, and then the pandemic hit. That put our whole everything on hold as the entire world did. As the pandemic started to lift, we restarted our search again in 2019, and we actually said, look, let's take another fresh look now that the pandemic's over. And Jonathan and the Schmier and the Georgetown group are great, but I'll tell you that pre-pandemic in 2019, I went to look at their building, and while I was waiting outside to go in, they said, sorry, we don't want lab space in this building. So that was really pre-pandemic.
We didn't say lab space. We said we didn't want clinical medicine. We always love lab space.
You don't want clinical medicine, right?
So clinical medicine, which was less exciting to us.
And a lot of buildings, to John's point, a lot of buildings don't want clinical or any kind of medical type facility in their building mixed in with office users. So that's a challenge for wet lab space across the city. There are a lot of landlords and owners in New York City who have buildings that have maybe a lot of vacant space, but I can tell you that those spaces are not ideal for medical facilities or wet lab facilities because of those infrastructure restrictions I just spoke to you about. In any event, this search has been going on for for 2 years, pre and post pandemic, we started looking at 787. And again, as I said, it had all the right elements for us and the ceiling heights. And more importantly, as Jim pointed out, it had the footprint to allow for shaft space in the building. Wet lab space requires fume hood exhaust over some of the benches, and those fume hoods have to be exhausted to the roof of the building. So not many buildings in New York City have that capability, number one, to house that shaft space, and number two, to have the capacity on the roof to hold the fans and the cannon fans and all the mechanical equipment that accompany that. Matter of fact, I think 787, I know for a fact, their basement now is oversubscribed with the building's equipment and Mount Sinai's equipment to support our laboratory facility. So 787 provided a lot of unique opportunities for us. We're very excited about our relationship with Georgetown. We had an excellent team who were on this phone with Mitchell Jurgala and Vanderweil, who did an excellent job with us, and due diligence, and Hunter Roberts, who helped us in our estimating. It was quite a bit of it was a Herculean effort, but it took a lot of effort by the landlord and us to finally get to the finish line. We're very excited about our facility. I'll add also that one of the key components to this, our decision making, was Georgetown allowed us to have a separate entrance in the building with our own private elevators. So our patients, our scientists, we're not riding an elevator with, office people going to work during the day. So that was a very kind of key element for us from a medical standpoint. Having patients go up on a private elevator versus mixing with other people, I think, is more of a comfort for people in a multi-tenanted building also. So those are some of the key components of our search. This building provided a lot of those assets to us, and we're very, very excited about opening up. Hopefully we'll be open and operating in about 24 months. Along with our wet lab facilities, as John mentioned, we're going to have an ambulatory surgery center. We are going to have a breast surgeon, an orthopedics outpatient facility to see patients by schedule. So it's a very robust program, a mixture of wet lab research and clinical medical facilities.
Wow, terrific. That is a great description. And I certainly can sympathize with your efforts to find a place. When I was running the New York Genome Center, we looked at over 100 facilities in every borough. And, we looked at 519 West 54th Street before it was the Hudson Research Center. And truthfully, the landlord didn't want labs in that building. And it wasn't until it changed hands and Taconic bought it that an owner was actually willing to entertain that use. So I know quite, clearly what you were up against in trying to find the right place. And it wasn't until we got to 101 Avenue of the Americas and Ed Minskoff that we were able to find a place where we actually could structurally rearrange things to accommodate a permanent location for the New York Genome Center. So
yeah, it really takes a landlord, and we're very pleased with Georgetown to accommodate all of our infrastructure needs, and that's the key component. De Blasio in 2018, changed zoning to allow wet labs and office space. Now you can see how quickly that took off. It really didn't change anything. It didn't move the dial at all, because there are not enough buildings in Manhattan that fulfill that need. Unless you're like Alexandria, that's built out of the ground as a wet lab facility, and it is designed and engineered to accommodate wet labs. All the buildings in New York City are really built to accommodate office space and not wet labs. The simple fact that this was a automotive, factory for Packard lends itself to provide that infrastructure for a wet lab facility.
Yeah, a lot of the buildings on the west side are like that, right? They were old printing buildings, and so their bones and their floor to ceiling heights really can accommodate this use. And as you say, it's much easier to do in a ground up development, which is the project that we'll be talking about later on in May, which is the Cove JC, which was just announced and will be 1.4 million square feet of ground up life science space. So that'll be a great addition to the New York marketplace.
Yeah, I mean, we've done quite a bit on our own main Mount Sinai campus. The Hess building is fully occupied. We built that with a couple of shell floors. Mitch Simpler, who's on the call here, helped us do the engineering for that and did a great job. So we're very excited about that science building. So any new science building that's built in New York City is really moves the dial in the real estate sector.
Absolutely. So now I want to turn to Guggenheim, Jim Pass from Guggenheim Partners, who basically underwrote the tenant improvements for Mount Sinai with $100 million credit facility. And can you just tell us a little bit about your decision-making process and the kinds of factors that you evaluated when you decided to issue that credit facility?
Sure, and thanks for including me. And I think it takes one step back, I guess I would say, is that we looked at the opportunity and we really separated the real estate from the obligor or from Mount Sinai and Icahn School of Medicine. Because when we met with Jonathan for the first time, we understood that we really weren't going to get any access to any collateral in a true real estate deal. There wasn't a mortgage. There wasn't the traditional collateral packages that you would see if we're going to provide a loan. And so we looked at the opportunity much more as a revenue obligation or really from a general obligation of the tenants. And it's a very unique situation with Mount Sinai and Icahn and, with the cooperation and really their willingness to, I guess there's a guarantee that we were able to, to really use to build a revenue package or a collateral package that was driven by the overall credit worthiness and the essentiality of the services that we're going to provide in the building, not to the building, but to the two institutions. So think of a unsecured revenue obligation of an institution that is devoted and dedicated to needing wet labs. And based upon that and really the essentiality of the building, we felt comfortable going to our clients and really, trying to generate $100 million in loans to finance a portion of the renovation that they were needing. And after some long nights with the documents and so forth, we were able to, get a package that satisfied our needs, but also protected some of the real estate pledges and covenants that other lenders had already claimed in the building. So having a separate entrance not only was important for Mount Sinai and Icahn, it was also very important for us. So then we had access to the floors, so they had that essentiality, that materiality that they were always going to use the building if another financing that was used to renovate the building had credit difficulty. So in many ways, it was a condominium approach to a financing, but we really separated the real estate aspect to really more the revenue obligation of Icahn, and then with the support of Mount Sinai.
That's really interesting. So how does this transaction differ from, let's say there was a life science company, let's say publicly traded, let's make it, a credit facility. And they were going to lease a similar amount of space. How would your evaluation be different than from, this institutional transaction that you did?
I'm not quite sure it would be really different. I think it would just be more, we'd have to truly understand, the stage of the company the level of research, what type of end products, or if they have contracts for that bio research or really that medical aspect of it. Companies usually don't have endowments like, Icahn or Mount Sinai. So it really is that, what is their operating income? What is their, really the products that they're researching and developing? And if we think that that research is worthwhile and is going to produce a bottom line, then we would stress those revenues and then size a lease or size a loan based upon that. But it's the same credit fundamentals that we'd have to apply. We're not going to get the real estate. So we really have to focus on their ability to, generate revenue as well as control their expenses to honor their loan. And so
they have to be generating revenue like in the immediate sense, not in the future sense.
I think it's both. I mean, if you have a new medical device or a new drug, and there's going to be some, and if you have a contract over so many years, that contract revenues may start low and ramp up. We're very comfortable lending against that revenue stream or that cash flow. But ultimately, it boils down to, if you're not getting real estate, you have to get comfortable somewhere. And so in this case, whether it's a not-for-profit or a for-profit, it really is how important is the building to the mission of that company or to the institution? And can they have the credit worthiness to honor their obligation based upon the essentiality of those services? So that's how we look at it.
So even for a company that had raised substantial amounts of money, but was still in the R&D phase in terms of they're pursuing products, but it takes quite a bit of time to get these products through clinical trials and, all of the development that they need. Is there some proxy that you could use, like the strength of the venture capital commitment, or the type of science that's being pursued in the market that, the market potential for that?
Right. I mean, there is, and I would say that probably the venture capitalist is probably the better spot. I mean, this was an investment grade loan. Our clients predominantly are insurance companies, pension funds, and sovereign wealth funds and other strategies. So they were looking for a fixed rate obligation, not equity. So if you're really going to support, a young company, the venture capitalist and more growth opportunities look in equity. And so they're willing to, have that nominal return, if any return, for the first few years, and then ultimately, see that hockey stick impact, that the returns are much greater. But when Jonathan approached us, this was much more of a fixed income loan facility. And so as a result of that, our credit analysis had to focus on the credit worthiness of Icahn and really focus on their ability, to survive revenues, because we didn't get the collateral. So we had to look for another security package that we felt comfortable with based upon how the building was designed and how important it was for these labs to the overall mission for Icahn. And we got comfortable there and were able to place the loan or generate the loan.
The whole process just demonstrates the requirement for a lot of creativity, at all levels, not only on the design level, but on the building owner's level, on your level. Just trying to make a transaction like this happen, you've got to be moving all of the pieces around a lot until you get it to snap in, right?
That's very true. It's a big puzzle.
Yes.
I'd add, Jim and his colleagues at Guggenheim, there are very few groups who are as facile, as sophisticated as Jim and his colleagues to be able to sort of take this on and get it done. Because in the background, we have a CMBS loan that encumbers the entire building, which adds a layer of complexity for those who have interactions with special servicers. It layers on a level of complexity that you're into sort of PhD finance trying to deal with this and structure around it. And,
Right.
Multiplicity of levels that we had to create in order to retain depreciation, have structures that were real estate tax efficient. And so when you actually look at an org chart now of our ownership, what used to be complex is now to a point mind numbing. But, you know, it was with Jim and his colleagues at Guggenheim, their perseverance to help us get it done, that we were able to do so. So you're absolutely right, Nancy. And there's a lot more on the backside that doesn't get to see the light of day, that is critical in getting these deals done.
Yeah, I'm sure. So let's switch gears a little bit now and look toward the present and the future, and talk to a few of the service providers who are now tasked with making this multi-tenant, multi-use building into clinical and lab space for Mount Sinai. So Steve Dietz, do you want to say a little bit about how Mitchell Gargiola is approaching this challenge?
Oh, that'd be great. And Nancy, thanks for including us. And it's actually been really interesting just hearing all the different elements that went into making this all work. You know, we come in at what is now obviously the tail end to try to take what Jim and Jonathan had created at this site and make it work for Mount Sinai. And I just wanted to mention at the beginning that Mitchell Gargiola teamed up with NK Architects when this proposal first went on the street, because Tom had kind of put together a proposal that was a fairly challenging combination of wet lab space, which Mitchell Gargiola has particular expertise in, and then clinical space, which is a completely different animal. And NK obviously has excellence in that sphere. And so it was literally on the walkthrough that you know, Paul Drago and I met, and we said we should team up and do this together, because it's a perfect combo project. So that's sort of how that was launched. And if you go to the next slide, you know, we first of all, just from a big picture standpoint, I want to just echo some of the things that Tom had mentioned. You know, there's a catchment area issue here for life sciences that I'm sure everyone has thought about. Mount Sinai West is sitting right over there on 10th Avenue and 59th Street. And as Nancy and others mentioned, you've got these great, you know, strong boned buildings in the immediate area. And I think that it just speaks to the likelihood that more and more of these developments are going to catch fire. The building stock is, you know, for someone like me who is working on adaptive reuse issues every day and being challenged by Mount Sinai to find the right building to do what we need to do, which is, you know, wet lab research, which, as Tom mentioned, requires a bunch of infrastructure and annoying headaches with, you know, ceiling heights, etc. When you see a building like 787 11th Avenue, you get excited. You say, hey, this can really work. Next. I also threw in this slide that Jim had. It's, you know, these old, you know, strong, can take a lot of structure type buildings are perfect for the kinds of things we're doing. The wet lab spaces, many of you know, have an enormous equipment loads. We need buildings that have a lot of structural integrity, good access from the ground floors for freight, roofs, and you know, cellars that, you know, as Jonathan pointed out, can be anticipated to be used by us, because we've got a lot of infrastructure we got to put in there. So this building, you know, really fit the bill. Next. And I thought it was interesting when Jim was going through his presentation, you know, you saw his sections were all about, this is going to be an office building. And, you know, a lot of the ceiling heights here are not enormously high, but I think Tom will remember that the moment of truth was when we went to this 8th floor, and it was particularly tall. It's a 15-foot nominal floor to floor. The windows that Jim had put in are amazing, and, you know, great light and view, which really matters for these lab spaces. I mean, people are in these labs working extensive hours. As Tom mentioned, the column spacing at 30 by 30 was, you know, a perfect spacing for lab development. The deeper floor plates were a significant part of why this worked. We could put a lot of contiguous wet lab space all together on one floor. The base building infrastructure, as Jonathan and Jim mentioned, they had put some effort into, you know, they specifically pointed out on the day we walked the vertical shaft space that was available to get to the roof. And, you know, we've had to do more than that, actually, as we've developed the solutions. but the fact that that was there made an enormous difference. And as we've already mentioned, the space on the roof and in the cellar made a big difference as well. Next. And you know, Mitchell Jurgen has been working on these adaptive reuse issues overall in the city, and we sort of created this brief diagram. I've touched on many of the things as we approach new buildings and say, is this the right place for wet lab? These are the 12 or 13 key threshold issues we look at to make sure this is going to work. The building height overall, you don't want it to be too tall or too short. The floor to floor has to be high. The floor loading has to be significant. The column spacing we've mentioned. Also power coming into the building. We hadn't touched on that yet. There was significant power provided on day one at this 787 site, 11th Avenue site. And it's been extremely helpful not to have to go back to Con Ed after going through a loop of thought process on that issue. Next. So going back to the stacking diagram, and I was thinking about it again, compared to yours, Jim, here, you've got offices as you develop them on top, and now we're changing that sixth floor, that seventh floor, and that eighth floor into research, clinical, and the ambulatory surgery center. And that is taking up the center of the building. And that eighth floor research at 44,000 gross square feet is really going to be a significant new floor for all the wet lab research. The clinical goes on the seventh floor, which is made a bit smaller by that double height space that Jim mentioned, and Paul Jago will show you a little bit of that. And then we ended up with research in the ASC on the sixth floor. And the other big story of this diagram that I wanted to just really harp on is, despite the good amount of infrastructure that was in place on day one, all the yellow is the additional infrastructure we need to inject into this building to make it work for wet lab space. And that included taking up a good amount of space on 4, 5, and 6 on the roof and in the basement to really put a whole new central plant in, which Joan can speak to a little later, that the research space is going to operate directly off of our own new central plant. Next. From a program perspective, Tom gave us a bunch of great researchers to work with. There's a core lab group looking at genomics, stem cell, CRISPR, proteomics, and a drug discovery institute. There's going to be a neurology and neuroscience lab component. There's a cancer research component. The vivarium, Tom already mentioned, is pretty significant, and there's additional recruitment labs. Next. And just to give you some data, we're going to end up with 60,000 gross square feet for research floors, 234 overall occupants. There's going to be 31 projected PIs in the building, 170 wet lab bench sheets overall, which is a lot of space for wet lab research. The 4,000 cage vivarium. There's also dry lab workstations and a bunch of common areas. Next. From a sort of zoning perspective, this is the 8th floor fully built out, and we ended up with 2 very large lab sections of benches shown in blue, one that's going to run along the 11th Avenue side, and I think that space is going to be it's going to kind of have an appearance of like a machine for wet lab work with lab support just behind it, and then we've got a secondary wet lab benching area along the southern edge. And then up in the north west corner is the vivarium, which did well adjacent to the core that Jonathan and Jim had developed with offices and formal and informal meeting spaces in orange sort of dotted around the exterior of the building. Next. Just a quick axo of that same plan, just to kind of give you a feel. I think the exciting part will be the large open labs, that I think are going to have a really, almost grand feel to them when they're finished. Next. This is the large lab along the eastern edge. Each bench, wet lab bench, has an additional seat for dry sort of write up work along the window edge, and the wet lab benches march along the center bays. And you can see the 30 by 30 spacing, how incredibly advantageous they were. Columns not getting in your way very often. Next. And architectural section, which kind of just shows you how important the ceiling height really was on that 8th floor. The density of mechanical in that center zone over the top of the wet lab benches is significant. And it still allows, we're sort of heading for a 10-foot 6 ceiling in there, and then leaving the outer edge along the eastern edge completely open ceiling, which I think will have a nice industrial feel to it. Next. And as Tom mentioned, getting a presence on the street became important for clinical, which Paul's about to talk about. So this is Jim's elevation, and we're inserting ourselves on that right-hand side of the 787 main lobby that Jim talked about. Go to the next slide. And so, well, you know, Mount Sinai ends up with a nice presence on the street, directly adjacent to the 787, you know, primary entry. And as Tom mentioned, it made a big difference to have this entry, you know, dedicated for particularly the clinical side of things. The researchers will also use it, but you know, the clinical side of things, these are patients coming to the building and they need to kind of feel comfortable they're headed in the right direction. And that's exactly where Paul can talk a little bit about the clinical piece, which was on the 7th floor.
Yeah, so interesting. I mean, one of the things that jumped out at me immediately is having the vivarium on the 8th floor. You know, given the requirements for servicing that area and removing waste and other things, what kind of changes did you have to make to accommodate that?
It's definitely been challenging. The vivarium requires so much overhead service requirements that the 8th floor was almost non-negotiable. We needed the vertical space. We needed that, you know, 6 and 7 do not have the same ceiling height availability as 8 did. So it really needed to be there. And actually, you know, Joan, maybe you could talk a little bit, Joan's with Vanderwaal, about you know, from an access perspective, it wanted to be in that back edge because we have direct access to the freight elevator, as you were saying, Nancy, because, you know, we obviously need to get down to that 1st floor. And we've got some additional storage for them in the basement, which is also directly accessed off that freight. And then additionally, kind of putting that vivarium in that quadrant allow us to kind of control the air and smell a bit more. You know, freeing up the rest of the site for the wet lab space. And Joan, I wondered from a infrastructure perspective, you could maybe add kind of all the elements that go into making that work.
And Steve, you promised me no smell, right? I mean, there was no
smell. No, Joan promised you. She's the engineer. I'm just the architect.
Just making sure.
Yeah, no, thank you. Certainly, that's among for sure the highest priority. Obviously, it's a very high intensive airflow space. You know, you have to get a lot of air in and out of that area, and a lot of utilities in and out of that area. So I think, you know, certainly a goal was to locate the space as near to our shafts and as near to our MEP equipment spaces as possible. You know, we did make it a priority, you know, to look at the pressurizations, add airlocks where needed, understanding that, you know, we cannot communicate smells to any other areas, and, you know, we don't want to communicate smells anywhere else on the floor. So really having it as contained and controlled in terms of pressurization as possible was a high priority. You know, also having utilities outside of the space so that you don't have to enter it for service reasons. You know, all the mechanical equipment is located in mechanical rooms outside the vivarium. You know, all of the exhaust goes up to high plume dilution fans on the roof. And, you know, also everything's redundant. That was another huge priority, just to be able to have additional equipment spaces near our program area where we can have systems that don't allow for a single point of failure. So, you know, if a fan goes down, you're not seeing a blip in airflow. You know, if a humidifier goes down, you're not seeing a blip in the environmental conditions. You know, and certainly all the emergency power and everything else that goes along with it, you know, is all baked into that scheme.
Yeah, so one of the, I think, other pioneering aspects of this building is, you know, that you've got office tenants alongside these really heavy duty lab uses, which includes a vivarium. And I'm wondering, Jonathan, when you announced, was there any reaction from other tenants in the building or perhaps residents around the building, wondering about fumes or other things?
Short answer was no. Part of the space is occupied by a co-owner of the building, so he was well aware of what was going on. And I think we had evidence to the other tenants in the building through the juxtaposition of the automotive uses that we were able to isolate noise, smell, vibration pretty well to keep a Class A office space. Right. And so that credibility, having built up over the last several years of having multiple uses in one building, allowed us to feel comfortable that with professionals like Joan and her team, that they would be able to plan to not have any impact to the other office users.
Yeah. One interesting thing about, mostly these uses have occurred on campuses, as Thomas alluded to, academic campuses. And there's lots of heavy duty lab space and vivarium space throughout the city, actually quite close to residential neighborhoods. But because it's, they've got an exclusion under the zoning for the academic institutions or an educational use, there's not a lot of attention being paid to that. But now that we're getting more commercial uses in the city, I think you're seeing some of the residential and others looking at this use and kind of questioning it. I think you're seeing that with the New York Blood Center, for example, and some of the comments that have been made about the tower that they're planning. And it's an educational process for the city, to help people understand how important this industry will be to New York's future and how you can mitigate, these kinds of effects that might come from the lab, so that it can exist side by side with an office use or a residential use. So Paul, do you want to talk a little bit about integrating the clinical here?
Sure, this will go a bit quicker than the others, but next slide. So basically, our portion of the project is an outpatient facility with 3 departments: imaging, breast, and spine center. The imaging really supports the breast center, but it also supports spine and outpatient, so that offers degrees of efficiencies. We're always medical fit outs, even outpatient clinics are so expensive that the whole charge is to define spaces that can have multi-use. The really interesting part, I think, about this clinic is less about what's going on inside of it, but its proximity. Although it hasn't been discussed that there's a synergy or an interaction between these clinics, that possibility certainly exists. And I think Mount Sinai was perhaps prescient in placing a clinic adjacent to research, because this is a trend we're seeing increasingly in the life sciences industry. So there's no reason why the breast center, the spine center cannot help support the cancer research programs upstairs. I'm not saying that's going to happen, but that is a possibility and an exciting synergy that I believe will happen once they realize the advantages of this placement. Next slide, please. Clinical program broken down on the left with 21,900 for the clinical floor. What these renderings don't show is the floor on is the last floor of the existing structure, which has the big mushroom columns. And these views, it was a real interesting challenge to design. The clinic layouts have smaller spaces, so the thick columns and the column capitals became a real issue. But we made them design features. These, you're just seeing some typical spaces from Mount Sinai's design standards: an exam room, the MA workstations in the hallway, and the 2 waiting rooms. And you see the metrics on the side. Next. Okay, and this is our planning diagram with the spine center to the right. It's a little hard to read. Breast center on the top and imaging to the left. We were very sensitive to the breast center, that the imaging, breast was the primary user of imaging. So we created separate access paths to the imaging center from breast, separate from spine and outpatient. Things like the green, which is staff support, is shared. One thing that was a Mount Sinai standard, the doctor's offices are along the perimeter, getting the view and the light. And we created very efficient arrangement with the MA workstations in the hallway between the doctor workstations and the exam room. So it was a very highly efficient from a space standpoint as from an operational standpoint. Let me see. So that's pretty much our portion of the project, and we just finished the bid documents, and we're looking forward to getting started. One thing I would like to mention, Nancy, is NK's also worked with a lot of your other partners, and we've had good experience with Eva Kramer at Biobat and SUNY Downstate. We've recently completed with Hunter Roberts a fit out of a floor at Downstate, excuse me, at Biobat. And I just want to mention quickly, it's very interesting that Eva Kramer is really clever at getting grants. I know it takes a lot of time, but she works with the borough president, city council, and she also works with you know, the city agencies, and she's managed to get over $80 million of grants to build the infrastructure for the project she's done.
Yeah, that's an amazing project and one that we are going to look at some point in the future. So
Okay.
It's on our list. We do have a question for you. What additional features, if any, were needed to incorporate in the building design in response to COVID-19?
Well, COVID-19, what we're doing is we're anticipating the future. So waiting areas, we're going to provide more room than they usually use. But you know what? I actually want to speak to my healthcare planner and designer, Elizabeth Sullivan, who would be able to give you more details. I apologize that I don't have that at my fingertips.
Okay, terrific. Brian, do you want to talk a little bit about, you know, how you got involved in the transaction and the challenges that you see and kind of bringing this home on time and on budget?
Sure, Nancy, thank you. Clearly, we have a lot of work ahead of us. It's nice to see some of the history here, but you know what really aligned Hunter Roberts here. I'm sorry?
Is your camera on?
It is now. Sorry about that. So we got involved at 787 over 3 years ago, working with Georgetown, doing some interior fit out work, finishing up some of the core and shell upgrades. So we had been in that building for a number of years, successfully working with Jonathan and with Joel, and expanding that relationship that we've had for a long time with Georgetown. In addition, we've done many jobs with Mount Sinai over the years successfully. And in conjunction with that, we at Hunter Roberts and myself have done a number of these, you know, commercial building upgrades. Nancy, you mentioned the New York Genome Center earlier. We have also completed the stem cell project, which is right next door. We've done, as Paul had mentioned at Biobat, we did the original upgrade at Biobat for all the infrastructure upgrade, and we've done a number of fit outs there as well. So it really aligned that our talents for this type of work and our relationships with the people that were involved with this project really was almost like a perfect storm. So it really worked out well. We got involved with Mount Sinai early, you know, to help them and looking at some of the budgeting that was necessary for some of the spaces that they were evaluating at the time and working with Tom. So it's really been a very positive relationship to this point in time. As Paul mentioned, you know, one of the challenges that we have here is that the clinical space is being brought online much quicker than the life science space. So we have a space within the building, the 7th floor, which has got to be occupied prior to the 6th and 8th floor. So from a construction perspective, it gives us a number of challenges from an infrastructure, from a shaft space, from an overall building coordination. We're kind of taking a floor out of a sequence. And, you know, from a hoisting perspective, as something as simple as that, we have to put the windows back. It's aligning with an MRI room. So there's a lot of challenges in getting the 7th floor space, you know, operational while we're still going to be working on 6 and 8. So it requires a lot of forethought because we have mechanical systems on the 7th floor that serve the 8th floor from a plumbing perspective that have to be completed, that we're never going to get back in those ceilings again. So that's really the major challenge here. I mean, the fit out component of this, you know, it's a significant amount of work. As you know, as Steve showed the drawings, there's a lot of laboratory casework here. And there's a lot of typical challenges with this fit out, but we're excited to be involved with it. And, we're looking forward to a successful completion, hopefully at the end of next year.
And what challenges are you anticipating from a building that's occupied by, office occupants?
Well, we are going to be touching just about every floor in this building for one reason or another. You've seen some core images of some of the shaft space we're going to be going in. There's an extensive amount of roof work that we're going to be doing. So, and then we have, extensive work in the cellar, and then we're tying all of that together vertically through the building. So we really are going to have to be working closely with Georgetown. We have one group of tenants at the bottom. We obviously have much more, we have other tenants up at the top, more classic office tenants that are going to be more susceptible to noise. And we want to make sure that they're happy with us. So we're planning on doing a lot of things off hours, all noise generating type work to be done off hours. So, there is a significant amount of coordination when you're working in a building such as this. So we're already in the middle of that right now. And, we're looking to finish that up, and we're hoping to get our demolition started on 6 and 7 next month. So we're really going to get, this thing is going to happen very quickly.
Wow. Well, that is an amazing story, everyone. And so thank you so much for participating in this conversation. I apologize that it went over by about 20 minutes, but I just thought that the content was so important and so fascinating that we really needed to just keep covering it. Does anyone have any questions that they want to ask before we drop into our discussion rooms?